Hey, all you HVAC engineers and contractors out there. My name is Wade McCorkle. I'm the regional sales manager for Samsung based here in Denver, Colorado. I support CFM in their VRF design and sales. And in today's video, we're going to be talking about a better way to design VRF in cold climates. Specifically, we're going to be looking at the Samsung Max Heat unit. This is a specially designed low ambient heating outdoor unit, which provides 100% nominal heating capacity all the way down to -13. A huge benefit of this technology is that it can provide peace of mind and confidence to the building owner, the design engineer, and the installing contractor. It can also eliminate the need for auxiliary heat or the need for putting the outdoor units in a heated mechanical room. And another big benefit is you can avoid upsizing your outdoor units, which can save money for the project. And we're going to dive into that specifically. Every VRF manufacturer is going to publish derated heating performance at various outdoor temperatures. And when we're working with air source heat pump technology, it makes sense that we have a derate as temperature decreases because there's less heat in the air for the outdoor unit to extract and bring into the building. When we look at the range of standard outdoor units among the major brands in the market today, we see this kind of performance curves. We look at this range specifically between -4 and -13, which are the typical design temps for the front range. Those standard units are providing anywhere from 55 to 85% nominal heating capacity. So it's quite a bit of a derate. And what we find in the typical design procedure is that those outdoor units are then upsized slightly, maybe 1, 2, or 3 sizes, depending on the design temp and the heating load requirement to overcome that derate and satisfy the building. A different and potentially better way to design is using a high heat module such as Max Heat. Like I mentioned, it provides 100% heating capacity down to -13, which that factor is unique even among other high heat modules. This could eliminate that need to upsize. However, there's another benefit that Max Heat can provide, which can lead to downsizing the outdoor units. What we find when we overconnect the outdoor unit is that it actually increases its capacity. So let's put some numbers to this to quantify it and try to understand it better. When we use an example showing a 16-ton outdoor system connected to 20 tons of indoor unit, so that's 125% connection ratio, and we're using a downsized outdoor unit. When we look at the derated or corrected capacities that this system can provide, in both cooling and heating, here's what we see. In cooling at 95 degrees ambient, that 16-ton nominal outdoor system is actually providing close to 20 tons of capacity, 124% of nominal. And that's meeting the needs of those 20 tons of indoor unit. And we see similar results on the heating side. It's providing 125% of nominal at 5 and 0 degrees, then drops off slightly at -5 and -10. But that performance is still very high and very unique in the market right now. If we were to look at this system example with a standard VRF outdoor unit, you'd probably see that you needed 22, 24, possibly 26 tons of outdoor unit to satisfy the needs of those 20 tons of indoor unit based on your ambient design temperature for heating. The reason for that is that derate that we just saw. You need to upsize in order to meet the heating load requirement of the building and the space. So in addition to using a smaller outdoor unit while providing the necessary heating and cooling capacities, we find other benefits with Max Heat. Compare Max Heat to an equivalent standard system, we find that COP heating efficiency is anywhere from 10 to 15% more efficient for Max Heat. We see that IER cooling efficiency is anywhere from 10 all the way up to 30% more efficient for Max Heat. Refrigerant charge is 5 to 15% lower for Max Heat. This makes ASHRAE 15 compliance easier. When we look at outdoor unit quantity and footprint, Max Heat is typically the same and in some instances actually smaller than the standard systems. The only design caveat is the electrical service is typically higher for Max Heat. So both MCA and MOP are slightly higher than the standard system. However, it's a nominal difference. The MOP may be 1, 2, sometimes 3 breakers higher. And the MCA is typically still in the same wire gauge, but sometimes you may need to increase that wire gauge by 1 size. And then the biggest design factor of all, everybody's worried about the bottom line. When we look at the equipment cost, Max Heat is actually 10 and sometimes 40% less expensive than the equivalent standard system. So as you can see, this is a brief overview, and it's a very compelling design strategy. If you want the full details, please check out the video in the link above. It's a 35-minute deep dive into this design strategy. It goes through specific system examples and the data to compare across all these different factors. If you have any questions, please reach out to your CFM company sales representative. We are always happy to help. Otherwise, thank you for your time and attention, and stay safe, Colorado.